In this problem, we have an airplane that is accelerating at 3.8 meters per second squared, and we need to calculate this, the total force exerted by the seat or the cockpit on a 75 kilogram pilot that will model as a point particle. So the mass is 75 kilograms. So we can start by considering the accelerations involved. So the airplane is accelerating at 3.8 meters per second squared. That's 3.8 meters per second squared. That means that the cockpit is actually exerting a force in the same direction as the airplane is accelerating, and it also has an acceleration of 3.8 meters per second squared. And there's also a force vertically downwards, and it's the acceleration due to gravity, and that is equal to g is equal to 9.8 meters per second squared. Now we can resolve these forces. So what I like to do is actually resolve the acceleration, 3.8 meters per second squared acceleration, into its vertical and horizontal components. Now since the angle 18 degrees is made such that the vertical component is opposite to the angle, it's given by the hypotenuse times the sine of the angle. So that would be 3.8 times sine of 18 degrees. And that means that the horizontal component is given by 3.8 times the cosine of 18 degrees. Now, note that the acceleration due to gravity and the vertical component of acceleration are in the opposite directions. So to find the total magnitude of acceleration in the vertical direction, we can go ahead and subtract 9.8 and 3.8 times the sine of 18 degrees from each other to find the total magnitude of the vertical force. And that gives us 8.626 meters per second squared as the acceleration in the vertical direction. And this is actually vertically downwards. So let me correct the arrow. So that's vertically downwards. And we have an acceleration that is 3.8 times the cosine of 18 degrees horizontally in the rightward direction. And so we'll evaluate this expression as well. And that gives 3.614 meters per second squared of acceleration in the rightward direction. So the total acceleration that's exerted by the cockpit looks something like this. So there's the vertically downwards direction, that's 8.626 meters per second squared. And then there's the rightward direction, and that has an acceleration of 3.614 meters per second squared. And the resultant we can simply find by using Pythagorean theorem. So the resultant r is equal to 3.614 the whole squared plus 8.626 the whole squared, and there's a square on r as well, so we can take the square root, squared is 8.626 the whole squared. And we can use a calculator to evaluate r, and that will give us the total acceleration as 9.9.35 meters per second squared. So that's the total acceleration. Now we can use Newton's second law, which states that the force is actually equal to the mass times the acceleration. So the mass is 75 kilograms, and the acceleration we just found out to be 9.35 meters per second squared. And that gives us our final answer as 701 newtons. And that is our required answer. So F equals 701 newtons.